Hello everyone, welcome to this video. Well, this particular video is all about the public key cryptography and the public key infrastructure. So in this particular video we'll be seeing up how exactly the public key encryption works and how the certificate authority used to provide the certificate and how the client is able to fetch those certificates. So the very first and the initial part we'll be discussing about the lab setups. So in this particular video we'll be using one of our system, that is Ubuntu. We'll be using it as a certificate authority which will be providing the certificates, and another Windows machine will be using it as a client, so that particular machine will be using those certificates. So let's begin with that, and first of all let's see how the scenario works. So moving up further, we have set up our labs. So the very first thing is what we are using is the Ubuntu, which will be our certificate authority, who will be providing the root certificates to our another Windows machine, which is this one. So well, in this particular thing we'll be using a OpenSSL server. So to do that we should be the root user, and in that particular operating system I have already downloaded the OpenSSL. So currently I am using OpenSSL version 1.0.1, which is a very old version, and most probably it will be attackable with the heartbleed attack. So my recommendation, if you are using the live environment, you must upgrade it, and if you are implementing it, so you must implement the latest version. So for the demo purpose I'll be using the 1.0.1, and I'll be making you the clear scenario like how the certificate used to work. So the first of all we need to configure our SSL server. To configure this we'll be simply running a command, a script which is predefined whenever you download the OpenSSL. So we'll be configuring that. Okay. Now the another thing is we need to compile these all scripts. So to compile it we'll be using make, and first of all we'll test the make, like either it's compatible or not. Okay, so finally it's compiled. Don't worry about these errors. Okay, now the next thing is we'll be installing up the compiled part. Now after compilation and the installation, our first target will be to become a certificate authority. Now what exactly is the certificate authority? So basically, a certificate authority is a trusted provider who is capable of issuing the digital certificates. And as in the market, there are several certificate authorities, and out of those several certificate authorities, there are certain reputed certificate authorities whose certificates will be taken as the root certificates. Now, what are the root certificates? Whenever your system boots up or whenever you enter into your browser, so if you go to some certain legitimate sites such as Google or certain sites like Yahoo and all, so it will never prompt you to add the certificate. But if you are visiting a non-legitimate site or a non-reputed site, and if it is using certain certificate mechanism, certain public key cryptography, then you will be prompted to add that particular certificate into your browser, because that is a non-root certificate. So let's take an example. Suppose if I visit google.com. So here if I visit google.com, see, as it is using the HTTPS, the secure socket layer, and it is using certain certificate authority mechanism, but still it won't prompt my browser to add the certificates into this machine. Now in the same manner, if I browse this particular machine, so it will say that your connection is insecure and you need to add the certificates for that. You need to add the exception, and here it will show you the certification details. And these are the fingerprints. So this is how it works. Now let us go back to our OpenSSL machine, and we'll be creating a scenario where we'll be creating certain certificates. So the very first thing after installing the OpenSSL, you must know that there is a configuration file in OpenSSL. In order to use OpenSSL, you need to create certain certificates, and to create certain certificates you need to configure that file. So the path for that file is user libraries SSL, and here if you see, you will find a particular file that is openssl.conf or CNF. Now this particular file, what it will be containing is if you open up this file, this particular file will be containing the configuration of your OpenSSL, like which directory will be keeping the certificates, which directory will be keeping up your issued certificates, and which is the default directory which will be keeping your new certificates, the database index files and everything. Okay, so here you can configure it accordingly as per your organization is concerned. Okay, so moving further, how to issue a particular certificate. To issue a particular certificate, there are three OpenSSL command basically. And those three OpenSSL commands are CA, request and X509. With OpenSSL you need to give this particular switch for this command as per your requirement. As I have told you, we need to generate the self-signed certificate for our certification authority. What this means is that the certification authority is totally trusted and its certificate will be served as the root certificates. So to create a new certificate, what we need to do is we need to go to this particular path where we have installed our OpenSSL, and we'll be running a command that is OpenSSL, and we'll be requesting the new certificate -new and with -509 -key out, and we'll be giving a name, let's say certification authority.key, and after that we'll be creating the certificate, and the format or the extension for that particular certificate will be CRT, and the configuration file which it should take is the same configuration file which is present under this directory, that is openssl.cnf. X509. Okay, now it will ask you to enter a PEM. Now what that particular PEM means is, PEM is privacy enhanced mail. It's a base 64 encoded certificate, which is you can say that it's frequently used by the web browsers or the web servers, as they can easily translate into the readable data, and we can even edit it using the normal text editor also. So we need to encrypt it, and with our key which we'll be providing to it, we can set it up anything, but you must be aware that you must remember that. Now here we need to enter up our country name. Let's say if I am in India right now, so I'll enter again, and the state, will be providing it some state name, let's say Telangana, and we'll be providing up the city, and the organization's name, and organizational unit, let's say researcher, and common name, let's say Abhishek, email me@iambhishek.sharma.com, okay. So this particular certificate has been created. Let's see. As you can see that ca.certificate and ca.key has been generated. Now let's see what's there in ca.key. Okay, so you can see this is our key file, which is encrypted with our private key which we provided. So moving further, we have seen that how we can easily create up our own certificate. Now our next task is we want to become the root certificate authority. So what we'll be doing for that is, let's say if our first company is, let's say, abhisheksharma.com. Okay, so for this particular company we will be assigning certain certificates. So we'll be doing up that OpenSSL generate using RSA algorithm and with the AES 128 cipher, and the output will be saved as server dot key, and the encryption cipher will be of 1024 bits. We need to enter the passphrase or our private key. Okay, so it's created now. As you can see that we have created our key. So we cannot able to see any of the data inside that key because it has been encrypted with our private key. If you want to see, we can even see that. RSA and -in server.key, and we want to see the text format of that. So it will ask us for the private key. Once we enter that, you can see the base 64 encoded part of your private key. Now this part can be easily decoded, but if we encrypt it and we'll see it without passing our private key, then you cannot decrypt it easily. See, we are using here the RSA algorithm and we are encrypting it with our private key. Okay, so now what we are going to do in our next part is we'll be generating a certificate signing request, or the CSR. So why we need that? Once the company has the key file, or once any of the organization have that key file, it should generate a certificate signing request, which basically includes the public key of that particular company. So now the certificate signing request will be sent to the certificate authority, who will generate the certificate for that particular key. Okay, so let's see how to do that thing. So we'll be doing that OpenSSL, then we'll be requesting up the new key -key, and here we'll be passing that key which we generated in our previous step, because we need a certificate for that particular key. -out, and here we need to specify for means the name of that particular certificate. So let's say server.csr, and the configuration file, again we'll be giving the default configuration file for the OpenSSL. Okay, now I need to enter the same passphrase which I entered for service.key, otherwise it won't generate the certificate. So now it's asking us to generate the certificate, so it requires certain details like the country name, the state, let's say Telangana, and the city, let's say Hyderabad, the organization, let's say LearningLynks, and the organizational unit, let's say researcher, and the common name, let's say Abhishek, and the email address, again I'll give me@iamabhisheksharma.com. okay, now for this particular we need to enter a challenge password. The optional company name, let's say LearningLynks. Okay, so now you can see that we have successfully generated our certificate for this particular key. Now here in this particular lab we are again and again using a particular X509 term. Now you must be thinking that what is X509? So X509 is means you can say it's a type of a digital certificate that is widely accepted over the international standards, and it is used generally for the public key infrastructure only. So why we use this? It is used to verify that a public key which is shared that belongs to the legitimate certificate authority or not. See, in the real world scenario, what I can do is I can intercept the network traffic and I can start generating my own certificates. The same which happens earlier in the SSL strip attacks. So what nowadays it's being implemented is we'll be using X.509 certificate. So what that particular thing is doing is it will be verifying that certificate that either that particular public key belongs to the legitimate authority or not. So that is the reason we are using X509.